In the ensemble methods, you've seen there are several variants which are basically either by bagging or boosting or stacking. Boosting is one of the most powerful technique in context of ensemble methods. As you all know, ensemble meta algorithms are basically repetitive loops or control loops over basic iterations. Like for example, we see that random forest is a bagging algorithm over decision trees. So similarly, boosting has several variants, some working over decision trees, some working with others. But the idea of boosting is a meta algorithm where we combine several weak classifiers. Let's see one example, and we'll see that all of them are basically following the idea of combining several weak classifiers to get a combined predictor or a classifier, which is better than one single classifier. So let's take the most popular boosting algorithm, namely adaboost. It was the earliest boosting algorithm, and there are small variants of all of them, but most of them work on the same principle with minor variation in the way the combination function is used. But let's take adaboost as an example. Adaboost works on the principle that you first run your classifier on the original data and you run it first. Then it is possible that you have done a classification based on that. Now, what happens is it's never perfect in the first sense, right? There's some accuracy. So there are some misclassified samples at each level. Suppose this is the first classifier, the first iteration you've done on your tree. This is the first classification in form of classification tree you build, and you find that there are some misclassified examples, like say this is a misclassified because it is X in the pluses domain, or this is a misclassified. Similarly, suppose there is another plus here, and suppose there is another plus. So these are all misclassified samples in the original problem, which have been misclassified by the first iteration of the classifier which you have obtained. What adaboost does is it increases the weights of misclassified samples in the current iteration, so that now we have much larger data items corresponding to here. And what happens is, now probably you may get a better classifier, which is probably, same data, but now suppose this is able to separate out the earlier misclassified versions better. So what happens is, in this case, we are concentrating on only those data items which have been misclassified in the first iteration to be classified correctly in the next iteration. Same way, now we see that there are several misclassified in the next version. We'll go on to a third step. So we can go on to a number of steps, maybe up to 10 steps, 20 steps, where each iteration you are boosting the misclassified data items and increasing their weight so that the probability of getting into the training sample is higher and they are better classified in the next iteration. You do the classification again, and then again, and again, but then when you come to the end, you probably have 10 classifiers. The first one, C1, C2, C10. You don't discard any of them. What you do ultimately is, you try to create a weighted combination in terms of weighted combination of all the 10 and give the resultant classifier, which is basically going to give you the final classifier which you are going to use for any original new data. So what you've done here is you've taken the step of iteratively identifying misclassified data and boosting that to get better classification in the next one, and in the end we are actually using the combined classifier of all the classifiers to give the net classifier, which is important from the perspective of not only being able to address deficiencies in the previous class, but also being able to improve the overall classifier accuracy. And this weight is determined by how well that particular classifier has performed. So weight is assigned by what is the accuracy which you obtained by that particular classifier. So what you need to understand is, this is the basic principle of any boosting algorithm, where you iteratively improve the classification accuracy of by looking at misclassified samples at each stage, looking at increased weight for them, and then increasing the weight for that, looking at that to be properly classified in the next iteration, and so on. Here you work on the entire input data at any point of time. You don't work on small random samples within the whole data, but you instead work on the entire data. That's why number of iterations is not something like 200 or 200, but something like 10 or 20 or maximum 25, 30. So if you see, boosting based algorithms are higher in accuracy than typical one-shot decision tree or a one-shot support vector machine or some algorithm like that. So boosting variants like adaboost. There are other variants which are basically slight variants of the same principle, where the combinations are created slightly different. Like for example, we have a GBM, which is a gradient boosting machine, or xgboost, which is basically looking at same thing but doing it in a parallel fashion. But they are basically using the same concept of boosting misclassified at each stage, using the weighted combinations of all the classifiers together, or combination of all the weak classifiers to create one strong classifier. So in that sense, boosting is a very powerful ensemble machine learning algorithm for classification or category of algorithms. And this is one of the most popularly used set of algorithms in any data science